In the last video, we used the right side of each small interval to determine the height of a box. Here, let's try using the left side of each interval to determine the height of a box. Let's start at this end because the other end gets a little bit confusing. So I'll have a box from 0.75 to 1. I'm still using 4 boxes. So I'd go up from 0.75 to the function and over and back down, and that's my box area. And here I'd go up to the function, over and back down. Here I'd go up to the function, over and back down. And now what? Well, I'd start here at 0, go up to the function, which is going up 0, and then over and then back down. So it's hard to draw, but I guess I'll just put like a super bold line here. There is a box there. It has a width of 0.25 and a height of 0. So that's why I didn't do that at first, because it's kind of confusing. Is there a box there or not? There is. It's just a 0 height box. So let's say what are our box areas? That box has a height of f at 0 and a width of 0.25 minus 0. What's the height of this box? It's f of 0.25 and a width of 0.5 minus 0.25. What's the height of this box? It's f of 0.75 times a width of 0.75 minus 0.5. And the height of this box is, oh, I'm sorry, I skipped a box there, didn't I? Let's cross that out and write it again. So 0.50 times 0.75 minus 0.25, 50, and f of 0.75 times 1.0 minus 0.75. Phew! So if you add that all up, you get the total estimated area under the curve. And what can you say about how that estimate of the area under the curve relates to the true area under the curve in this case? We get an underestimate or a lower bound, in this case, on the true area under the curve. LB for lower bound on the true area under the curve. All right, and then what can we do with our spreadsheet form? Got the same basic setup as before, but now instead of having a blank here for the width, I'd say the width is 0.25, which would be C7 minus C6. C7 minus C6. Got a C. Let's compare that to what we had in the previous sheet. We had C7 minus C6 for the right-hand method, but it was in the row 7 rather than the row 6. So that's really the only big difference we're doing here. We're doing calculations kind of one row earlier. And then this f of x times the width, we do d6 times e6. We'd fill those down, except we'd have a blank at the end instead of at the beginning. And the running sum, we'd say g6 plus this value here, which is what, f6. So in the previous example, remember right now we're doing the left-hand side, but in the previous example we did g6 plus f7, we were one row down, but now we're doing it f6. So we would get a final answer here. So we'll say this cell would be our final answer. But we see all the little steps along the way. we see kind of the area adding up and up and up. Another way to do it would be to say in this cell, underneath all that work, sum F6, F7, F8, and F9. So it's like before, but it's one row higher up because we're doing everything on the left, which is the earlier side. So that's the left-hand method and the right-hand method, and what else could there be? We'll find out in the next video.